So in this domain, we're going to discuss different protocol stacks. We're going to see what do we mean by a stack. In fact, we have layers on top of each other, and this is called a stack. We're going to see why do we have multiple layers, what are the different functions of each layer. We're going to start at the top from the application layer and go all the way down to link layer. We're going to see different protocols at each of this layer and how these protocols are interrelated. So we're going to start with the protocol stacks, OSI and TCPIP. Then we're going to discuss different protocols such as HTTP, TCP, UDP, IP, ICMP, and how do they work. Then we're also going to have a look at key network protocols which are used for providing security. So we're going to discuss, for example, IPsec. We're going to see what is TLS, SSL, and how do they provide security collectively. This is an important domain because cybersecurity relies heavily on good concepts of computer networks. So let's start with OSI and TCP/IP. So basically, the concept of a stack is that we have multiple layers, such as you see here, for example, in TCP/IP, we have physical link, network, transport, and application. And these layers are stacked on top of each other. The basic idea or the basic motivation is that we want to have layers which perform specialized functions. We don't want one piece of code or one layer to do everything. So that's why we specialize layers, and then we can design each layer independently. So for instance, if I want to introduce a new protocol at the transport layer, I should be able to do that without affecting other layers. So that's the basic idea of layers. They offer abstraction. I can update the transport layer or the network layer or add new protocols or modify existing protocols. And I don't even have to worry about, breaking the stack or, affecting the performance of other protocols. So this is the basic idea of layers in computer networks. Now, layers, they offer two major advantages. First of all, you can make changes in any layer. And secondly, you can add new protocols at any layer without affecting other layers. Now, coming to the main point, we have two big protocol stacks or two popular protocol stacks, OSI and the TCP/IP. Now, OSI is a 7-layer protocol stack. The key point to understand here is that OSI was basically a theoretical model. It never got materialized, and we don't actually have implementations of OSI. However, you're going to hear the word OSI and its layer a lot as you progress in computer networks, or if you're doing courses in cybersecurity or working in the industry. And there's a reason for that. Even though OSI does not actually exist in real implementations, but it did provide the theoretical foundations on which the TCP/IP protocol stack, which is actually implemented these days, it works. So basically, TCP/IP was basically built onto the foundations provided by OSI. And that's why we still refer to different layers of OSI from a conceptual perspective. Now, so the fundamental difference between the two is that OSI is a theoretical model, whereas TCP/IP is a practical model. It's actually implemented. An interesting thing to note is that TCP/IP is a de facto standard. By de facto, we means that it never really got ratified as a standard. However, it got adopted so widely that it became a standard. People started using it, companies started fabricating network devices based on TCP/IP, and the usage became so widespread that TCP/IP became the de facto standard, and hence now we have the TCP/IP protocol as perhaps the single largest protocol stack in the world. So let's start with the TCP/IP protocol stack. Now, TCP/IP is a 5-layer protocol stack. It has the application layer, transport layer, network layer, link layer, and the physical layer. So starting with the application layer, now this is the layer which runs user applications. So for example, if you have Skype running on your system or Internet Explorer, it will be this layer which is running that application. Now this layer interacts with users and allows users to, input data or, see the data. Next, the application layer relies on the transport layer for actual application to application delivery. So what this means is that, let's say you have Skype running at the application layer and you type hi on Skype and you press enter. You want to send your message to your friend who's sitting in another part of the world and he's also using Skype. Now the application layer is going to ask the transport layer to take your hi message and deliver it from your application to application running on his system. So the transport layer provides application to application delivery. In turn, the transport layer needs the help of the network layer because first, before your message gets delivered to the destination application, to the destination Skype, it first needs to reach the destination, right? So your message first needs to be sent by the network layer using routing to the destination computer. And the network layer uses IP addresses and does routing, all that stuff, so that your message gets delivered to the destination computer. Once it's there, it's once again the job of the transport layer to deliver your data from that computer to the Skype application. Now, in turn, the network layer needs the help of the link layer because you see, network layer does the end-to-end routing. It sends your data from your source computer to the destination computer all across the internet over multiple routers. It calculates the routes. But for each individual jump or each individual link, the network layer actually needs the help of the link layer to take your packet from one link to the other, or one device to the other device over a single link. Next, we have the physical layer, which basically converts your bits from zeros and ones to electromagnetic signals, which are then transmitted over the wires or the wireless medium. Now let's have a look at the concept of layering. Why do we have layers in the first place? So basically what happens is that, let's say you type a message hi on Skype. Now your message will be sent to the transport layer because the application layer cannot directly deliver this data to the destination. So it asks the help of the transport layer to do that. Now what the transport layer does is that it adds its own header, which you can see here, transport header TH, and encapsulates this packet. So basically hi becomes the data and transport layer adds its own header, which includes information which helps it deliver the data to the correct application on the destination. Now this whole packet is then sent to the network layer. A network layer basically considers all of this as data and adds its own header, which is the network header. In the network header, the network layer adds things like routing information, IP addresses, source and destination IP addresses, stuff like that, so that it is able to route your packet over the internet. Now this whole thing is sent to the link layer, which basically considers the hi message, the transport header and the network header as data and adds its own header. Now the link layer header contains information which helps the link layer deliver your packet over each individual link. Finally, we have the physical layer, which converts basically your data from 0 ones to electromagnetic signals, which then get transmitted over wires or wireless medium depending on which technology you're using. And now when your packet reaches the destination, so what happens is that the process is reversed. So basically the link layer is going to check the link header, extract the information, do the necessary processing, and then pass on the remainder of the packet to the network layer. The network layer is going to extract its information from the network header and pass the remainder of the packet to the transport layer. And finally the transport layer processes its information, removes its header and passes the message hi to the application layer. So this is how it's done. The message gets passed to different layers through the protocol stack and delivered to the destination. Now let's have a look at the concept of protocols in the stack. Now basically what happens is that we have lots of different protocols which reside at different layers of the protocol stack. And we have quite a lot of flexibility in any combination that we want to make. So for instance, in this example, we have HTTP, which uses TCP at the transport layer, which in turn uses IP at the network layer, and then they use wired protocols at the link layer. So it is the stacking of protocols, for which we call it the protocol stack. Now we have several dozen protocols at each of these individual layers, and each protocol performs a certain specific task. So for instance, the HTTP protocol is used for web browsing. So this is the protocol which helps your web browser into fetching information and showing you web pages. Then we also have the SMTP protocol, which helps in sending and receiving emails. There's another protocol which is FTP, which helps in file transfer, and we have so many others. Similarly, at the transport layer, we have TCP, UDP, STCP, and several others. At the network layer, we have IP, ICMP, but a point to be noted here is that IP is the fundamental protocol at the network layer. And we are going to discuss later in the course that IP is one protocol which will always be used, almost always be used. There are a few exceptions when ICMP will be used, but generally speaking, all of the communication on the internet, it's done through IP protocol. And then on the link layer, we have both wireless protocols and wired protocols. If you see the destination, we have almost a corresponding stack. So again, we have IP, TCP, and HTTP. Obviously, at the link layer, we're free to use. For example, we may be sending data over wires here. We may have an optical connection to the internet, and here we may have a, let's say, Wi-Fi connection. That's fine. But for the other protocols, they need to be the same. So if you're using IP here, you'll be using IP at the destination. If you're using TCP here at the source, then you need to use TCP at the destination, and similarly HTTP at the both ends. So the basic concept once again is that you have different protocols which reside at different layers, and then you stack a combination of these protocols, and this is what makes a protocol stack. This concludes the discussion on protocol stacks. I'll see you in the next lecture. Thank you.